Hey, hello, welcome back. My name is Prosper Ngongo, and in this lesson we're looking at carbon and its compound. Remember in our previous lesson I told you that we're going to look at carbon and its compound and it's going to span for 4 weeks. We started with carbon as an element. We looked at the allotropes of carbon. We talked about the amorphous forms and the crystalline allotropes of carbon. We dived into talking about diamond and graphite, its properties and uses. Next, we look at coal, where we discussed the destructive distillation of coal. And lastly, in our last lesson, we looked at coke, where we talk about the gasification of coke, and talking about producer gas and water gas, its uses. And we also answered some critical thinking questions, which was fun for me. I don't know about you. But in this lesson, we're looking at oxygen, oxides of carbon. What are the oxides of carbon? So let's look at our objective for the lesson. Our first objective for the lesson is you should be able to state 2 oxides of carbon. At the end of the lesson, you should be able to state 2 oxides of carbon. And the next one is you should be able to describe the laboratory preparation of this oxide. How do we prepare these oxides of carbon? And lastly, you should be able to state some properties and uses of this oxide of carbon. Let's not waste time. Let's begin. What are the oxides of carbon? Now we have 2 major oxides of carbon. Now the first oxide of carbon we're going to look at is carbon monoxide, also known as carbon 2 oxide. But for our lesson, we're not going to focus on carbon monoxide because of our scheme of work and questions that are likely to come out in our exams, WAEC exam. So we're going to focus on carbon, the next oxide of carbon, which is referred to as carbon 4 oxide. So we're going to focus on carbon dioxide, which you well know, also known as carbon 4 oxide. Now, a lot of students have problems identifying the names carbon monoxide and carbon dioxide. You tend to wonder, I don't understand. It's called carbon monoxide and also known as carbon 2 oxide. But while writing the chemical equation, you just have CO for carbon monoxide. Then where is the 2? Oh, you need to go back to our previous lessons. You shouldn't forget those lessons. Those lessons I've told you in the past that's important. How to write chemical equation and IUPAC naming. Now the 2 here stands for the oxidation number of carbon. Now carbon has 2 major oxidation states, +4 and +2. So the 2 here says that a carbon in this compound is +2. So, and that is why it's known as carbon monoxide or known as carbon 2 oxide, stating the oxidation state of carbon. Whereas on this side we have carbon 4 oxide, stating that carbon has an oxidation state of +4, and that is why the chemical formula is represented with CO2 as carbon 4 oxide. So a lot of students have a problem writing the chemical equation or finding similarity between CO2 and carbon 4 oxide. They ask the question, how is carbon 4 oxide CO2? I'm expecting to see 4 somewhere. Well, you should go back to your notes, those lessons you've had in the past about writing IUPAC names and chemical formulas. You need to revisit it, and if you have a problem with it, you can ask a colleague, you can ask your classmate, and they could help you out, or research it yourself. I believe in personal research. So let's proceed. Let's begin with the first one. Although it is arranged different here, we're going to be looking at it from the back upwards. So carbon dioxide. We all know of carbon dioxide from the first GIF picture we saw in our specific objective. You see this GIF where the human is breathing in oxygen and then breathing out carbon dioxide. We're all conversant with this right from the beginning, right from our primary schools, probably even the nursery schools. So how do we prepare carbon dioxide in the laboratory? Well, some of you are conversant with this apparatus. It's known as Kipps apparatus. Let's see. Now, laboratory preparation, how do we prepare carbon dioxide? The first one is using a trioxocarbonate. Now, for some of you that has attended our practical classes on Saturday, we've done some of this equation. So this is limestone reacting with acid, HCl, to give us a salt, water, and carbon dioxide. This equation could also be found in regards to the chemical properties of acid. which you did last time, we were told that acid reacts with triazocarbonate to liberate carbon dioxide. So you can prepare this, and this is the principle that the KIPS apparatus work on. Or we don't want to dive into how the KIPS apparatus work, but basically you have the acid going in from up here, pouring down to this point and rising up to this layer where you have this marble, also known as limestone. On this layer, the reaction happens. There's a reaction around here and the gas is produced, which can be collected here. Basic. So the next laboratory preparation is decomposition. You could just place this ordinarily and just heat it up. When you heat it up, it will decompose, break down to give us calcium oxide, a base, and carbon dioxide. So we're used to this. This is the one we're most conversant with and we most agree with in the laboratory, because you just simply put it up, set it up, and you have a constant stream of gas, carbon dioxide flowing out. Simple. And the next one we're going to look at is the reaction of a carbonate, the hydrogen trioxocarbonate, with nitric acid. So it's similar to this, but it's different in the sense that this is an acid salt. A hydrogen trioxocarbonate is just a basic trioxocarbonate. So we have this reacting with this to give us the same salt, water, and carbon dioxide. Let's proceed. Now in this segment, we're looking at the physical and chemical properties of carbon dioxide. These properties are really simple. The first one we're looking at is it is colorless, odorless, and tasteless. I don't think this is going to be difficult for you to know, to memorize. And it's a wide question though. You'll be asked to state the physical properties and chemical properties of carbon dioxide. And the first one you should just opt in for is colorless, odorless, and tasteless. Really nice, smooth. The next is about 1.5 times denser than air. In other words, it is heavier than air. Basic. Number three is soluble in water. We're going to talk about that in the chemical properties. And lastly, it readily liquefies and solidifies at minus 78 degrees Celsius to form a white solid known as dry ice. Now in the past, I used to think that dry ice is solid water that is dry. You won't blame me. It is called dry ice. But how can ice be actually dry? And that was a question I used to ask myself. I know there was a flaw in my thinking, but I could not put a finger on it. And I was not exposed to the internet, so I didn't have that. So, but dry ice in this case is solid carbon dioxide. If you want to know more about it, please browse it up so I don't take a lot of time. So chemical properties. For our chemical properties, I'm only going to deal with equations to illustrate how important our chemical equations are. Most students would want to shy away from writing chemical equations in the chemistry class or dealing with chemical equations entirely, like avoiding it. That's impossible. It's impossible. This is the language of chemistry. If you find it difficult to write chemical equations, I would want you to go back to it and deal with that properly. If not, you have a problem on hand. So, carbon dioxide, we're told that carbon dioxide is soluble in water. So what happens when carbon dioxide dissolves in water? Carbon dioxide becomes carbonic acid, an acid, a weak acid, carbonic acid, also known as hydrogen trioxocarbonate 4. The next is when you pass carbon dioxide into an alkali, like a base, an alkali, soluble base, you have a carbonate, sodium trioxocarbonate being formed, and water. Now this equation is important because you find questions in WIEC that tells you how, or asks you, how do you remove carbon dioxide from a sample of air? To remove carbon dioxide from a sample of air, you pass that air into an alkali such as sodium hydroxide or potassium hydroxide, and you remove carbon dioxide because it reacts with sodium hydrogen trioxocarbonate or any of the alkali to give you a carbonate and water. But in the presence of excess of carbon dioxide, it will move further to give us calcium hydrogen trioxocarbonate. So this is important. In fact, they're all important. Number 3, carbon dioxide being reduced by magnesium. So magnesium has a tendency, burning magnesium has a tendency to reduce carbon dioxide to give us magnesium oxide and carbon. This question comes out most times. I told you that carbon dioxide is the most important of the gases, of the two gases, and why it focuses on the physical properties, chemical properties, and the uses of carbon dioxide. All right, moving on. Number 4, carbon reacts with carbon dioxide. It is reduced. We're going to relate this later on in regards to carbon monoxide. Look here that carbon monoxide is produced in the process. So we have carbon monoxide being produced when red hot carbon reacts with carbon dioxide. We have carbon monoxide. And we're going to also look at a similar equation in regards to the chemical properties of carbon dioxide as we move further. So remember these equations. If you find it difficult if you think it is difficult, just pause the video and give it a second look. I believe that you'll understand and get it more. When you pause the video and give it a second look, read through it again, and you are good to go. Moving on. Test for carbon dioxide. Now this aspect is really important. How do we test for carbon dioxide? Now, a lot of you looking at this be like, oh, this is a whole lot. Believe me, it's not. Let me try to simplify this. Now you just need 2 reagents to test for carbon dioxide. Although in WAEC the question will not be how do we test for carbon dioxide in the laboratory. Well, I'm going to tell you how the question would look like. The tendency, how it will look like in WAEC. But I'll first describe the test for carbon dioxide and then move on to what happens when you advance or when you move further in regards to the chemical equation. So 2 things you need. You need your lime water. Now what is lime water? Your lime water is calcium hydroxide in water. So when you have calcium hydroxide dissolved in water, it's referred to as lime water. Now the other component, the other thing you need is your unknown gas. So let's look at this video. Let's take a look at this video over here. Now what happens is this is our lime water, clear, yes. Now we have a tube inserted in this test tube. So when you bubble carbon dioxide into lime water, what you have is a milky mixture. What happens is lime water reacts with the carbon dioxide you're bubbling into it and gives you an insoluble solid, an insoluble compound, calcium trioxocarbonate. Calcium trioxocarbonate is insoluble in water and so resulting in the formation, this milky formation. So but what happens then? What is this standing for? If you keep bubbling carbon dioxide into this mixture, it reverts back to being colorless. Not the same, but it reverts back to being colorless. Now what happens? What has happened? Chemically, what has happened is, look at this, calcium trioxocarbonate, which is insoluble, the milkiness, and the water, which is here, and we keep bubbling carbon dioxide. What you have is the formation of a new compound, calcium hydrogen trioxocarbonate. It is different from this, the formation of this, because this is soluble while this is insoluble, therefore resulting in a colorless mixture or solution. Lastly, which I didn't write here, is when you hit this mixture, this last one formed, it reverts back to this. Because of the decomposition, the backward reaction happens. So it reverts back to the formation of this insoluble solid. Now how do I ask it? They will not ask you, most times you will not be asked to test for carbon dioxide. You'll be asked to write all the whole process, the processes by way of the questions will go like, what would happen? What happens when carbon dioxide is passed through lime water? A, for a while. B, prolonged passage. And D, the product formed in II is heated. So you'll be asked to go through the whole process. And from what I've described, it's not difficult. Let's summarize again. Lime water, carbon dioxide being passed into lime water. Remember, lime water is calcium hydroxide in water. The milky color is formed because of the formation of limestone, which we also know as calcium trioxocarbonate. On prolonged passage of carbon dioxide, you have calcium hydrogen trioxocarbonate, which is soluble in water, making it colorless. And when you heat this, it reverts back to this. Simple. So all we have left is the chemical formulas. You should know the chemical formulas, how to write the chemical formulas. Let's proceed to the next oxide of carbon. Now, the next oxide of carbon is carbon monoxide. We're told that it is the silent killer. Ooh. Well, let's see why it is the carbon silent killer, or probably you would have to tell me. But first, let us look at the laboratory preparation of carbon monoxide, also known as carbon 2 oxide. So how do we produce it? Carbon monoxide is produced by the incomplete combustion of carbon compounds such as octane found in petrol. We told that it's carbon compound. So compound containing carbon, when you burn it incompletely, that is in limited supply of oxygen, you have carbon monoxide being produced. But in the laboratory, this is how we go about it. It can be prepared by passing carbon dioxide through a red hot coke. Now let me refer you back to the chemical properties of carbon dioxide. Remember, I told you the fourth chemical property. I told you that carbon dioxide, when passed through red hot coke, gives us carbon monoxide. Yes, that one, exactly. The same, it's the number one preparation tells us of the same process. It can be prepared by passing carbon dioxide through red hot coke. So you have carbon monoxide at the end of the day. Well, if you don't want to go about that, we'll go with the next one, which is by dehydrating methanoic acid or ethane dioic acid. So when we dehydrate, that is removal of water, chemically removing water from methanoic acid and ethane dioic acid, we have carbon monoxide. Now note this, you see how we cycle out the atoms that makes up water, one hydrogen, another hydrogen, and oxygen. So water is being removed minus water, and what we're left with is carbon monoxide. That is for methanoic acid. While on the other hand, for ethane dioic acid, water was cycling out, or we're singling out the water aspect. And what we have here is COO and CO. This COO results to the formation of carbon dioxide, and also carbon monoxide is formed in the process. So for carbon monoxide, because it's not so important in work, and we have seen some of its property, I will be seeing more of its property in videos that will be coming up. I want to stop at this point. This is the most important aspect in regards to WAEC. But what you'll be telling me, other things we've not looked at the uses of carbon dioxide, the uses of carbon monoxide, the physical properties of carbon monoxide, the chemical properties of carbon monoxide. But what I'm most interested in, another aspect that comes out as an objective question, is why is it carbon monoxide dangerous? In one way or the other, this question is going to be phrased. You have to answer why it is a silent killer, or as you see in the video, the silent killer. So moving on to our Google Classroom, I want you to comment as to why do you think carbon monoxide is the silent killer? You can look it up for yourself. It's going to be fun looking up for yourself. Type it online. Why is carbon monoxide the silent killer? And also remember, in our Zoom class, you could come up with some of these questions. Of course, not the ones I've asked you. You ask questions in areas you don't understand, from our previous topic down to this one, because it's the understanding you have now is going to determine your foundation in regards to chemistry. So remember our Google Classroom. If you've not done your assignments, if you've not done your classwork, please do so. It has to enable me keep track of your work. And for our Zoom class, we're going to have an interactive session where we'll discuss what we've done so far. If you have any question, do not hesitate to discuss it with me in the Zoom class. So do have a nice day, and remember, stay safe, and thanks for watching.